Everyone. Today I'll be talking about two very common problems in machine learning: overfitting and underfitting, and how we can identify and prevent them. These issues directly affect how well our model performs on real world data. So let's start. Now, in machine learning, our main goal is simple. We want our model to perform well on unseen data. This ability is called as generalization. But two problems often stop our models from generalizing properly: overfitting, where the model learns too much, and underfitting, where the model learns too little. Let's explore each of them in very clear and simple way. Understanding overfitting. Overfitting happens when the model memorizes the training data, including all the noise and unnecessary details. Signs of overfitting include very high accuracy on training data, poor performance on new data, the model becomes too sensitive to small differences. This usually happens when model is too complex, the training data is too small, regularization is not used. Basically, the model becomes a topper on training set but fails miserably in real world. Now let's understand underfitting. Underfitting is the opposite problem. Here, the model is too simple and cannot capture the real patterns in the data. Signs include low accuracy on training data, low accuracy on test data, model oversimplifies everything. Common causes of it is model is not powerful enough, not enough relevant features, too much regularization. It likes trying to explain complex behavior using a very basic rule. It's it simply won't work. Now let's identify overfitting versus underfitting. Overfittings look like training error is very low, test error is very high, big gap between training and test scores. Underfittings look like this: training error is high, test error is also high, both scores are similarly low. Monitoring these metrics during training helps us catch problems early. Now, strategies to prevent overfitting. To reduce overfitting, we can use several techniques. More data, more examples, reduce memorization, regularization like L1 or L2, reduce model complexity by using fewer layers or parameters, early stopping during training, dropout in neural networks, cross validation to check generalization. All these help the model focus on real patterns instead of memorizing noise. Now, strategies to prevent underfitting. To fix underfitting, we need to make model more capable, increase model complexity, reduce regularization so the model can learn more, add more relevant features, train longer, giving the model more time, use non-linear models if the relationships are non-linear. In short, we make the model smarter so it can capture deeper patterns. Now the balance. The bias variance trade-off. Overfitting and underfitting are connected through a bias variance trade-off. Underfitting is high bias, low variance, the model is too simple. Overfitting, low bias, high variance, the model is too complex. The goal is the sweet spot between the two. A model that is just complex enough to learn patterns but not so complex that it memorizes everything. Now, the key takeaways: to summarize, overfitting model memorizes the data, underfitting models oversimplifies the data. We detect them by checking training versus test performance. We fix them by adjusting complexity, adding data, using regularization, or choosing better features. Mastering these concepts help us build strong, reliable ML models. So, if you thank you for listening. I hope to understand the concepts of overfitting and underfitting in a simple and effective manner. Thanks for watching. Thanks for listening. See you soon.